lines and angles. So let's start the chapter lines and angles. So what is the meaning of line? A line is a set of points that has only one dimension, that is its length. 2 points are needed to define a line. A line has no end points, and points on the same line are called collinear points. So, this is the example of a line where you have to write the name of the line. So, we can take 2 points on the line as A and B. So, we can say AB is a line. Line segment. A line segment is a part of a line which has two distinct endpoints. We can also say that it is a link between 2 points. For example, if we have these 2 points A and B, so the distance between these 2 points A and B is the line segment. Now in every day we come across these figures: watch, fish, a scenery, an aeroplane, a house, a student reading, table, chair, scissors, and so on. Now, by observing these figures, we have something in our mind that these figures have different types of angles. So, the angles, two rays joined with a common end point from an angle, and the common end point is called a vertex. For example, if we have AOB, that is OA is a ray and OB is a ray, they starts from a vertex O, that is common. So the figure formed is the angle. So we can say AOB is an angle. Whenever we have to write the name of the angle, we have to use 3 letters or 3 alphabets to write the name of the angle, and the common vertex where the two rays starts, that should be in the middle position of the 3 letters. Similarly, in this figure also we have XY is a line and another line PQ intersect them. So both are intersecting at a point, that is M. So here we got the 4 angles, 4 different angles. We can name them X, M, P. Second angle PMY, third angle QMY, and the fourth angle XMQ. From any variable we can write, for example in this AOB we can write angle BOA also, but it must be ensured that where the angle is formed, that alphabet should be in the middle position of the 3 letters. Okay, now again these two lines, or we can say these two rays TR and RU, they are starts from a same point R. So At point R, there is an angle. So, name of this angle is angle TRU or angle URT also. So, remember, this is the sign of angle. In another way, we can write the name of this angle AOB is angle O. For angle XMP, we can write angle M. For XMQ, again we can write angle M. But here, as at the end point, there are forming four angles. So we have to write the name of the angle using three letters. Here, only one angle is forming with the rays RT and RU, so we can write the name angle TRU, or simply in one letter we can write angle R. Now some pair of angles. First is complementary angle. Now what is the meaning of complementary? So the sum of the measures of two angles is 90 degree, then the angles are called complementary angles. For example, 30, one angle is 30 degree and one angle is 60 degree. So sum of these two angles 30 and 60 is 90 degree. So we can say this 30 degree angle is complementary of 60 degree angle, or in another words, this 60 degree angle is complementary angle of 30 degree. And if we want to find the complementary angle of 30 degree, we have to subtract 30 from 90 degree angle. In the same way, when we have to find the complementary angle of 60 degree, so we subtract 60 degree from the sum of angles, that is 90 degree. So 90 minus 60, we will get complementary angle of 60, that is 30 degree. More examples of complementary angles are, one of the angle is 27 degree and one is 63 degree. So sum of 27 degree and 63 degree is 90 degree. So they are complementary angle of each other. Another example, one angle is 40 degree and one angle is 50 degree. So both are complementary of each other. Similarly, one more example, 20 degree and 70 degree. They both are the complementary of each other, as the sum of these two angles is 90 degree. So, how can we find the complementary angle of 20 degree? Yes, 90 degree minus 20 degree, so we can get the complementary angle of 20 degree. Similarly, for 70 degree, when we have to find the complementary angle of 70 degree, we will subtract 70 degree from 90 degree, so we get 20 degree. So we can say 20 degree angle is the complementary angle of 70 degree. Also we can say 70 degree angle is complementary angle of 20 degree. Now, you understood the concept of complementary angle, that the sum of two angles is 90 degree, then they are known as complementary angle. In the same way, when the sum of two angles is 180 degree, now we understood the concept of complementary angle as the sum of two angles is 90 degree. Both angles are known as complementary angle of each other. And now the concept of supplementary angle is when the sum of two angles is 180 degree, then the angles are known as supplementary angles. For example, one angle is 120 degree and another is 60 degree. So we can say 120 degree plus 60 degree is equal to 180 degree. So 120 degree is the supplementary angle of 60 degree and the 60 degree is the supplementary angle of 120 degree. So when we have to find the supplementary angle of 120, we subtract 120 from 180 degree. So we get 60 degree. And similarly, when we have to find the supplementary angle of 60 degree, we subtract 60 degree from 180 degree. So we get 180 minus 60 degree is equal to 120. So 120 is the supplementary angle of 60 degree. Let's explore some more examples related to supplementary angles. For one angle is 45 degree and the second angle is 135 degree. So sum of these two 45 and 135 degree angle is correct 180 degree. So both are known as supplementary angle of each other. One more, 110 and 70 degree. These two pairs are also known as supplementary angles of each other. 101 and 79 both are also the supplementary angle of each other, as 101 plus 79 degree is equal to 180 degree. So we can say 101 degree is the supplementary angle of 79 degree and 79 degree angle is supplementary angle of 101 degree. This is the supplementary of 79 and 101 is supplementary of 79 and 79 is supplementary of 101. They known as supplementary angles of each other. Now next pair of angles is adjacent angles. Have you seen your notebook or textbook? When you open that, you will get the adjacent angles. So the two adjacent angles have a common vertex and a common arm, but no common interior points are called adjacent angles. So in this figure, this is the B point. From B, one ray starts BA and the same point B, another ray starts BC, and there is one ray BD, which for that we are getting here two angles, angle A, B, D and angle C, B, D. Now these two angles are called as adjacent angles because they are sharing a common arm BD and a common vertex B. So these two angles are the adjacent angles. For example, this is the clock. All we have seen this clock as the minute hand and the hour hand. In between them there is a second hand. So this second hand is the common arm, and this point where all three hands of the clocks fixed is known as vertex. So this is the example of adjacent angles. Now next pair is linear pair. So a pair of adjacent angles whose non-common sides are opposite rays is a linear pair. For example, we all have seen in our home, this is the chopping board. Here at this center, the chopping board divided into two angles. So here this is the one angle and this is the second angle. So this is the pair of adjacent angles, and when the pair of adjacent angles sum is 180 degree, then the pair of angles is known as 180 degree or known as linear pair. So when the sum of two adjacent angles is 180 degree, then the pair of angles is known as linear pair. One more example. This is the example of road, where this is the common vertex, and by this point O, this line, that is road, divided into two parts and between the two angles. So the angle AOB we can say 180 degree, as this is the straight line. So we can say the two adjacent angles, when their sum is 180 degree, they are known as linear pair. In vegetable shop, we seen this. What is the figure of this? Yes, balance. In balance also we can observe the pair of adjacent angles, and at the point O, this point O, the two adjacent angles formed and they are A and B part there. So at point O, the two angles formed and their sum is 180 degree. So this is the linear pair. One more example. This is the figure of what? Can you tell me? Yes, it is electric pole. Now all we have seen this. This is the electric pole, and at this point this pole is divided into two angles, that is, here is two adjacent angles, and these two adjacent angles are on the line, this one line, and this is the 180 degree angle. So we can say this is the example of linear pair. One more thing, we use this scissor for our day-to-day life, for cutting some papers or for our craft work. So at this point again we are observing this scissor is divided into two angles, or we can say here are two angles are formed and they are the adjacent angles and their sum is 180 degree. So this is the example of linear pair, that is common vertex is there O, angle A and angle B, their sum is 180 degree and they are adjacent to each other. So we can say angle A and angle B are the linear pair. One more pair of angles is vertically opposite angles. Okay, so the two lines, whenever we saw the two lines intersect each other and we get the formation of any symbol like X, so we can say the angles formed are known as vertically opposite angles, and the vertically opposite angles so formed, they are also equal. For example, in this figure, CD and AB are two lines intersecting at this point. So we can say COB and AOD. These two are the pair of vertically opposite angles. Similarly, angle AOC and angle BOD, they are also the pair of vertically opposite angles. Now, look at these signs for the angles. There is, in this one, angle COB and AOD, they are showing only one curve or showing only one line segment for only one curve for the angle. So these two angles are equal and this highlighted by two curves. These two angles are equal. So we have the pair of vertically opposite angles are COB and angle AOD and both are equal. Similarly, angle AOC and angle BOD, they are also the pair of vertically opposite angles and they are equal to one another. Some examples in our daily life as we have seen are fan. Like this, we can say these two are the pair of vertically opposite angles and they are equal. Again, this is the table lamp. So, in this one table lamp figure, we observe this line which is highlighted with blue color. These two angles are the vertically opposite angles. Similarly, these two are also vertically opposite angles. So, as we know what is the line, so let's do the types of lines. So, first is intersecting line. Intersecting lines, that the lines which cut each other, or we can say the lines which intersect each other at a point. So that point is called the point of intersection, and the two lines which are intersecting each other are known as intersecting lines. In simple words, we can say when the two lines cut each other at a point, then that two lines are called intersecting lines. For example, a crossroad. This is the example of intersecting line. This is the railway track. This is also the intersecting lines where the two lines intersect each other. Now, parallel lines. Parallel lines, that the lines which do not intersect each other at any point, or we can say the lines which do not cut each other, are known as parallel lines. So, this is the picture of railway track. See, the tracks are not intersecting at any point, so we can say these are the parallel lines. See, in this figure, the railway tracks do not intersect each other. Similarly, here also the electric line for the railway track, for the rail, or for the train. This is the electric line. These are also parallel to each other as they do not intersect each other. So we can say the lines which do not intersect each other at any point are known as parallel lines. Now next is perpendicular lines. The lines which intersect each other and makes a right angle or makes a 90-degree angle is called the perpendicular lines. For example, here AB is a line and MN is the line which is straight on the line AB. So we can say here is the formation of a right angle. So the line BN is perpendicular to AB, or AB is perpendicular to MN. Our dining table, correct. In our dining table, there is also the perpendicular lines. So we have the types of lines are intersecting lines, where the two lines intersect each other at a point. The parallel lines, the lines which do not intersect each other at any point. And the lines which intersect each other at 90-degree angle, that is perpendicular lines. Now let's talk about types of angles. In our geometry, there are lots of angles. And in our daily life, we observe the objects, their corners. So we can say the corners have the angles, and in every object there are different angles, and the measurement of the angles are different in every object. So on the basis of this, there are two types of angles. First of all, the angles classified into two types. First is based on magnitude, that is based on measurement, and the second is based on rotation. So let's talk about first based on magnitude. So the angles based on magnitude are, in the mathematics, there are the angles which are based on the measurement of is first acute angle, second is obtuse angle, right angle, straight angle, and reflex angle. So these are the types of angles on the basis of the measurement. Acute angle, obtuse angle, right angle, straight angle and reflex angle. Let's talk about one by one. So here this is the figure and this shows this angle A is less than 90 degree. So we can say an acute angle lies between 0 degrees and 90 degrees, or in other words an acute angle is one that is less than 90 degree. So the figure this where the angle is less than 90 degree is the acute angle. Now in this figure, this is the obtuse angle where this angle B looks greater than the 90 degree angle. So we can say the obtuse angle lies between 90, more than 90 but less than 180 degree. So obtuse angle is the angle which lies between 90 degree and 180 degree, more than 90 degree and less than 180 degree. So the angle is known as obtuse angle. Now everywhere we are talking about right angle, right angle, right angle. So the right angle is always equal to 90 degrees. As we know, any angle less than 90 degree is an acute angle, and whereas any angle which is greater than 90 degree is an obtuse angle. So the middle value, or we can say 0 degree and 180 degree, there is a degree measure of 90 degree. So this 90 degree is known as right angle. So in this figure the right angle looks like this, or we can say this is the perpendicular lines also. So 90 degree is the two perpendicular lines also form a right angle, where the angle is 90 degree is known as right angle. Then a straight angle, always we have a straight line. So that straight line is 180 degree angle. So we can say a straight angle is 180 degree angle. Now the measurement is less than 90 degree. The angle forms an acute angle. But what about the angle on the other side? As in the previous slide we have taken the example of acute angle where the angle is less than 90 degree. So what about the another part of that angle? So that is the part which is more than 90 degree, and also you can say that is the reflex angle. For example, in this figure, if this is your obtuse angle, so when you complete the circle, this angle is 217 degree. So there is a complete angle also, which shows complete angle is total of measurement of a circle. That is a circle, an angle in the circle is complete angle, that is 360 degree. So the reflex angle is greater than 180 degree but less than 360 degree. Whenever we see the measurement of the angle is greater than 180 degree and it is less than 360 degree, that measure of the angle is called the reflex angle. Now the angle types based on rotation is when the based on the direction of measurement of the direction of rotation, angles can be of two types, positive angle and negative angle. So the positive angles are those angles which are measured in a counterclockwise direction from the base. In most cases, positive angles are used to represent angles in geometry. From the origin, if an angle is drawn in the positive x-axis and y-axis plane, it forms a positive angle. And when the negative angles are those which are measured in a clockwise direction from the base, from the origin. If an angle is drawn towards the x and minus y plane, it forms a negative angle. So we have altogether the 6 types of angles listed. This is the acute angle, where the angle measure of the acute angle is more than 0 but less than 90 degree is the acute angle. When the angle is measured 90 degree is right angle. When the measure of angle is more than 90 degree but less than 180 degree is obtuse angle. The angle which is equal to 180 degree is known as straight angle. The angle which is more than 180 degree but less than 360 degree is called the reflex angle. And when we complete one rotation, or when we complete a circle, that known as full angle or complete angle, that the measurement of the complete angle is 360 degree. So we have 6 types of angles: acute angle, right angle, obtuse angle, straight angle, reflex angle and complete angle.